Hi there. We're going to talk about the quadratic formula today. Quadratic formula used to solve a quadratic equation. All right, so your quadratic formula looks like this. Remember, we are solving an equation, so it's going to have the x equal component, not just this by itself, right? Negative b plus or minus square root of b squared minus 4ac all over 2a. A lot of people, sing it to a song, have some sort of mnemonic device to remember it. I teach one in my class, the one I used when I grew up. It goes something like this. There was a negative boy who was unsure if he wanted to go to this radical party, didn't want to be square and miss out on 4 awesome chicks. Went to the party that was all over at 2 a.m. Use it if you like it. If not, come up with something that works for you. All right, so we're going to break down this quadratic formula, and there's 2 key components, okay? If you recognize the part without the square root, without the plus or the minus, that's x equals negative b over 2a. Okay, we should recognize this as your equation for the axis of symmetry, right? X equals negative b over 2a. So when you think about this here, right, we connect the equation to what it means graphically. We know that all quadratics, when we graph them, are a parabola. So the first part of the quadratic equation is the axis of symmetry. This is the center of your parabola. It's where your vertex is located. Now, if you think about the symmetric attributes of a parabola, right, wherever the axis of symmetry is, there's going to be 2 sides of the parabola that are symmetric, the left side and the right side. And that's what this is here, right? The negative is to the left of it and the positive is to the right of it. Okay, so not only are we going to have the axis of symmetry, but we have 2 points, one to the left, one to the right of the axis of symmetry. And when we put all of this together, right, x equals, we're finding the solution, we're finding the x-intercepts. All right, so these are the 2 symmetric, or this is what's going to determine the 2 symmetric x-intercepts that are on the left and the right of your axis of symmetry. All right, hopefully that makes sense. It's a connection. If not, yeah, that's an upper level. All right, so the quadratic formula, QF, quadratic formula solves any quadratic equation. If it's a quadratic equation, this will solve it. Doesn't matter if you could solve this by using square roots, solve it by factoring, solve it by completing the square, any other method. If it's a quadratic, this will solve it. Okay, in order to solve or solve using the quadratic formula, we need to be able to distinguish or recall what A, B, and C were. Remember, A, B, and C were your 2 coefficients on the quadratic and the linear term, and of course the constant. All right, so A, B, and C could be positive and negative. And if you need to, or if your class discusses what the discriminant is, the purpose of the discriminant, it's going to determine how many solutions you have, 0, 1, or 2 solutions, even though keep in mind, all quadratics technically have 2 solutions. It's just we might define them in a different way, okay? And of course, what type of solutions they are. So you might have real solutions or you might have imaginary ones. Okay, and the discriminant is just describing the value b squared minus 4ac, or the stuff that's inside the square root. Okay, so in order to use the quadratic formula, right, the first thing that you need to be able to do is identify the a, b, and the c. So we'll start off with a couple of those. Okay, so make sure you can be able to do these, and you can come back, rewind anytime you want. Okay, so just look at this. And then if you think about it here, okay, so for the first one, what are the values of A, B, and C? In order, A, B, and C, I'm not going to write them down, okay? A, B, and C, A is 1, B is 2, C is positive 5. 1, 2, 5, A, B, and C. Second example here, A, B, and C in order, 2, negative 3, and 4. All right? Now, careful when you try this third one here. Hopefully you caught something here, okay? Whenever we're going to do the quadratic formula, whenever you are putting something in standard form, right, we need to make sure that we make the right side or the other side of the equation equal to 0. All right, so for this problem specifically, right, let me get a piece of paper here, wasn't prepared for that. For this problem here, right, we need to first change this into negative x squared plus 5x, subtract 2 from both sides, minus 5. All right. Only then can you decide what the A, B, and C values are. So now in this problem, a, b, and c respectively would be -1, +5, and -5. All right. Okay, going back here, now remember we said the quadratic formula can be used to solve any quadratic. So what happens if we look at a problem like this? You'll see that I have the quadratic term, the linear term, but there is no constant term. That's fine. The constant term is just the value of c. Okay, so your a, b, and c here, your a would be 1, your b would be -4, and your c would be 0. Okay, remember when you don't have it there, it's not a 1, but c is 0. Okay, and then similarly, I could have the quadratic term and the constant term with no linear term in the middle. So in this case, a would be 1, there is no linear term, so b would be 0, and c would be -6. Okay, now of course, b and c could be 0. A can never be 0. Okay, if a is 0, then I have 0x squared. 0x squared would just make that quadratic term non-existent, and therefore it wouldn't be a quadratic. Okay, so your a has to at least be something non-zero. B and c could be 0 or could be anything. All right, so just like I set up there, in order to use your quadratic formula, of course, you got to remember, first thing, put your equation into standard form, set the equation equal to 0. And then, of course, when you're deciphering what is a, what is b, what is c, always watch your positive and negative signs. Okay. Now, the second part that we had to identify, or that was the second part of the equation, is the discriminant. Okay. Now, the discriminant by itself doesn't mean anything. It's just a value. Okay. But whatever type of value that is going to determine something. Okay. So for this one here, calculate the discriminant. And the discriminant is nothing more than b squared minus 4ac. Okay. So again, you got to identify your a, b's, and c's. So for this one here, we'll say a is 1, b is 3, c is -6. So my value of the discriminant is just going to be b squared minus 4 times a times c. All right, what's that? 9. Negative is a positive 24. Okay. Now the 33 isn't important so much as that it's a positive 33. Okay. All right, let's look at the second example here. Again, a is 1, b is -6, c is 9. So here we go. My discriminant is going to be b squared minus 4ac. -6 squared is a positive 36. -4 times 9, -36. All right. Now this one's 0. It's not positive. 0. Okay, so the first one could come out positive, come out 0. And if you are ahead of the game, you can figure out what this one probably might do. Make sure I got standard form equal to 0. Here we go. A is 2. B is 1. C is 3. Calculating my discriminant, I get b squared minus 4ac. And that's going to be 1 minus 4, 8, 24. -23. Of course, the key here is that it's a negative value. Okay. All right. So let's just practice on calculating the discriminant. All right. Now, what does the discriminant do? What did we just calculate? Yeah. You're looking at the discriminant, and if you get the square root of something greater than 0, if you get a value, if you get greater than 0 for your discriminant, we're going to get two solutions because it's going to be a positive and a negative. And because we can take the square root of something that's a positive value, they exist. We're going to get two real numbers. Okay. The second case we did, if you have 0 as your discriminant, okay, your quadratic formula would say plus or minus the square root of 0. Well, there is no value to add and subtract, so you're not going to get two distinct numbers. You're actually going to get one answer, and if you want to think of it, it's actually still two answers. It's just going to be considered a repeated 0. Okay, and then the last case is what happens if your discriminant is less than 0, if it's negative. Well then, as it says down here, right, you're going to be taking the square root of a negative number. We should know that taking the square root of a negative number is going to result in an imaginary number. So then when I look at my quadratic formula, I'm going to get negative b plus or minus something imaginary, plus or minus I. Okay, that's a complex number. So then not only am I going to have two answers, but both of them are going to be imaginary. All right, so that puts together the whole thing here. All right, so let's go back to the quadratic formula, and let's actually use the whole thing, because more than likely, you probably came here looking just for an idea of how to do this. I gave you a little bit more. Okay, so remember, this is our quadratic formula. All right, so let's try a couple of problems here. All right, so solve. Okay, we're solving it here. Now, if you could factor it, nice. I can't do this with square roots, so don't worry about that. Completing the square, that's another lesson. That's actually going to give you fractions. Okay, here we go. Standard form, equal to 0. So I can do this. Here we go. A is 1, B is -7, C is 5. Okay? So whenever I have my kids in class do this, I always like to tell them to use parentheses. So let's go. X equals, it's going to be negative boy, negative b, plus or minus square root of b squared minus 4 times a times c. Okay, the reason I suggest using parentheses all over 2a is that whenever you deal with negative numbers, right, there's always that sometimes tricky thing, like what happens if there's a negative inside a square, what happens if it's negative outside a square, what do you get when you have a negative times a negative, things like that arise. So it's just to be a little bit nicer here. All right, so put it in here, negative boy, b squared minus 4ac all over 2a. All right, the rest of the problem becomes simplifying. 7 plus or minus, that's 49, negative 20. All over 2, we've got x equals 7 plus or minus root 29 over 2. All right. As you can see here, there is no imaginary because all the stuff that was inside the square root, the discriminant, is positive. When this is a positive number, I have two answers as a result, two real solutions. All right, let's try another one. Now this one's actually a special case. Now, you should definitely recognize this problem before we even go at it. This is actually a perfect square trinomial. All right, so what's special about this here? All right, let's go. A equals 1, B equals 6, C equals 9. All right, and I should have checked. I got standard form equals 0 before we start. So here we go, x equals. All right, negative. Again, just the setup. Sometimes if you just get used to the setup too, it helps you remember the formula. Okay, so negative boy, b squared, and set on 4, awesome. Chicks, all over at 2, a-n. All right, simplify this. Negative 6 plus or minus square root of 36 minus 36. All right, so we should recognize that. That's going to be 0. My discriminant is 0. Right? So here's the thing about the discriminant. When the discriminant is 0, we don't get this part. This part goes away, plus or minus 0, right? That's nothing. We don't add and subtract 0. So then my answer is just negative 6 over 2. I only have one answer. Okay, x equals negative 3. Now again, you've been guaranteed that there's two answers. Okay, if you solve this by factoring, you solve this by completing the square, you will get two answers, but it's a repeated 0. So you get x equals negative 3 and x equals negative 3. Okay, so this is technically one repeated, but still real solution. Okay. All right, so the first example we did, we got two reals. This one we got one real that's repeated. And then let's talk about this last one here. All right, x squared plus 5x plus 7, not factorable. All standard form, one side equal to 0. Here we go, a equals 1, b equals 5, c equals 7. X equals, I'll just put it all together now, negative boy plus minus square root e squared minus 4 times a times c all over 2 times a. Simplify this. X equals -5. All right, here's the part that tells me about the solutions. Square root of, that's 25. Minus 4 times 7 is 28. 25 minus 28, I'm going to have a negative discriminant. Right? Not only am I going to have a negative discriminant, plus or minus root of -3. Okay, now that doesn't mean I can't do the problem, right? We've learned about square roots of negative numbers. We can have imaginary solutions, and here we go. Actually, that is my answer, but let's put the I into it. Right? That should be I root 3 over 2. Okay, so clearly, here I have two imaginary solutions. All right, so that's basically it. But let me go back and do one more thing, just to kind of throw it in like a little bonus here, right? When I have two imaginary solutions, remember, when we tie this into, we tie this problem into solving, we tie it with the graphing, what does it mean? X, we're solving for the solutions, the roots, but graphically, remember, these are my x-intercepts. So if I have two imaginary solutions, that means my parabola, and this parabola, okay, it's not related, it's not this problem, but just in general, right? If there are two imaginary solutions, it's not going to ever touch. It does not have a real x-intercept. Okay, so two imaginary solutions, no real x-intercept. All right, if I go back to the last problem, this is the special case, right? There's always something special about this formula here. Well, this one, what happens, right? Normally my parabola will touch or dip or something, but these are the ones where the parabola is just going to touch one time. Okay, so right here, right, it looks like I only have one solution, but it's one repeated solution. All right, so one repeated solution. And then the first one, which is of course the most common ones here, right? Most parabolas, when we think about it, they're going to cross twice, usually once it dips below, and then of course once it comes back up. And then that's how we normally have two x-intercepts. Remember, here's my axis of symmetry, that's right down the middle, and everything is equidistant from each other. This is our common ones here, nothing imaginary about it, two real solutions. Okay, I hope this was helpful. Go back if you need to, fast forward, rewind as much as you need to, practice it, and good luck.